Hi, I want to welcome everybody to this introduction to the Fusion 360 API. I'm Brian Eakins. I'm the API designer for the API, and maybe we'll just give another minute here and see if some more people come in, and then we'll get started. Introducing Fusion 360, the API, and I'm Brian Eakins, and let's go ahead here. So, yeah, so to ask questions, there's a raise hand icon, or it probably better is you can type a question into the questions panel, and we'll watch for those as we go along. So, all right. So maybe just first, what is Fusion 360? And so it's been included into this Forge Hackathon, kind of separate Forge Hackathon and Fusion 360. So what is it? What does it have to do with Forge? And so here's my definition of what Fusion 360 is. A little bit long, but so a design, simulation, and manufacturing cloud-centric desktop application. Right? Let me go through what I mean by that. So design, so it's a modeling system, so I can use Fusion, and these are all parts models that I got. There's a gallery where customers can allow others to see what they've designed, and these are some of the models that Fusion customers have created and posted onto the gallery. And so Fusion can be used to design typical kind of industrial parts, like that upper left model is a steam engine, so those kind of things, but also more free-form, abstract kind of models that you see in some of the other ones. So a broad range of modeling is supported. There's also simulation. So you can use Fusion. So built into Fusion is also a simulation tool, so you can validate a model to see if it's going to be able to work under the conditions you plan to use it. And there's also manufacturing. So I've created a model, and now I need to actually produce it. And so Fusion supports what you see here is the creation of numerical control toolpaths to be able to cut a model. What I don't have a picture of, but also 3D printing. So I can create a model and 3D print it. So that's the design, simulation, and manufacturing part of the definition. So all that's built in to Fusion. And I also said it's a web or cloud-centric desktop application. And so first, the desktop application part of that definition. So when you go to the Fusion 360 website, and you can install Fusion from there. So it's installed onto your local hard drive, and it runs locally on your computer. Okay, it's not a browser that's talking to the web to be able to do the modeling, but it's running locally, and just through a standard desktop interface, like most other applications that you use on your computer. And because of that, it also will work when you're offline, because I have all of the code locally, and so Fusion can work when I'm on an airplane or I'm somewhere where I don't have internet access. I can still continue to work offline. And when I'm working, whether I'm connected to the network or not, the speed of my modeling, calculating toolpaths, doing analysis is independent of my network speed, because it is a local application. And it's provided for both Windows and Mac. So there's versions for both the operating systems. So that's the desktop application part of it. And then the web-centric or cloud-centric. So This first one's kind of simple, so that you can't get a CD or a DVD of Fusion, so it's installed from the web, and it's also automatically updated from the cloud. So when you start Fusion, Fusion checks if there is a network, it checks to see if there's an update, and if there is an update, it automatically pulls that down and updates your version of Fusion. So you're always up to date. Updates come out a couple of times a month typically, and so that happens automatically through the cloud. And this is the big one, and this is what kind of ties Fusion into Forge, is that all of your data is saved on the cloud using A360. So basically Fusion uses A360 as its file system. So when I create a new design and I click Save, it doesn't ask me where on the disk I want to save that. It asks me which project on A360 and which folder, and then when I save it, that gets copied up onto A360. And when I browse to open an existing design, I'm looking at what's on A360 and opening it from there. And so that's, like I say, what ties this into Forge, is that now I can use Forge APIs for any of the Fusion data because it's already on in the cloud on A360, and I have access to it through the Forge APIs. And also another thing that Fusion does is you can use the cloud for some additional simulation capabilities and for rendering. So it's optional. You can do some local, but if you want, in some cases, some more powerful, or to just offload that, you can use the cloud for that. All right, so Fusion has all those capabilities as an end user to let me model and simulate and manufacture my model, but it also supports an API, because as a user, a lot of times maybe I have this tedious process that I do over and over, and I want to automate that. So I take out the error, and I just don't like to do the same thing over and over and over and speed it up. Or as a third-party developer, I have a solution to something that I think Fusion users could use, and so I want to deliver that solution to them, and so this API makes that possible. And so the API, basically like Fusion, it's a local API, so it's running within that local copy. When I start up Fusion, it's running locally on my machine, and the API is running inside that local instance, desktop instance of Fusion. So if Fusion isn't running on a cloud somewhere and I'm not talking to that, I'm always running within Fusion on my local machine. There's a single API. So when I design the API, I actually design it in an IDL, or interface definition language. And then we have a tool that reads that API definition and creates the stubs function by the Fusion core, and then a developer goes in and actually adds the code to make those work. But so that's all done in C++. So it's these C++ functions are created and implemented, and then also that process that reads that definition language that created those C++ stubs, it also created a Python and JavaScript wrapper over those C++ functions. So it is really a single API with these three bindings to these different languages. And I'll talk later about maybe why you would choose one language over the other. And the API supports creating both kind of simple scripts. If I'm a user and there's just this process I do over and over, and so I just write a little simple script to help automate that, and more complex apps. I have this really sophisticated application that I want to deliver, and so it supports all of that. So just to get started on kind of what the API supports, a big part of that for both simple and these more complicated applications is you need to be able to just drive Fusion. So you want to do the same kind of things that the end user would do, but automate that. And here's an example. So I want to create a gear, and I can look up on the web and find out the formula for how an involute tooth is created, and get out my calculator, maybe write a little function in Excel that would calculate points along that involute. And so I get the points, I fit a curve through those, I mirror that curve over, so now I have the sides of one tooth, right? And I create an arc along the top, I extrude it, so now I have one tooth on my gear. I can pattern that tooth around, and now I have a gear. Okay. So as an end user, I could build the gear, but it wasn't very fun. And now I need a gear of another size, so I go through that whole process over again. So with an API, I can build a nice interface where it asks just for the gear parameters, click OK, and then it does basically what I just described, but it automates it. Right? So as an end user, it's simple. Here's another example where it wanted to simulate gouges in this wood, and so it's basically little partial toruses that have been subtracted out of the revolution big body that started with, that was created by a revolution. And so these little partial toruses are positioned all over the model, and I could do that interactively, but it would just be so tedious that I wouldn't want to get very far. But with an API, I can automate that process. All right, so here's where we are today as far as what the API supports with respect to what Fusion can do. And so Fusion is broken up into multiple workspaces, it's called. So if this upper left, you see model. So this is the modeling workspace. This is where you do 3D solid modeling. And so what this is showing is all of the commands that Fusion has for 3D modeling, solid modeling. And the things that are in green, the API has full support for. So I can create and edit and query the things that are shown in green, those commands. The things in yellow, it has some partial support for, and the things in white, there's currently no support for. And the things in white, so if there's a real need for it, we will add support for those, but most of those, they aren't either used very much, or they're not, there's other ways to do it besides that command that may be better from an API perspective. So here's another workspace is the patch workspace. This is for working with surface models rather than solid models. And so we have pretty good coverage there. A lot of the commands are the same between the two. And where we don't have any coverage, you can see the lines just drawn through. So these other workspaces, rendering, animation, simulation, and drawing, currently there's 0 API functionality for those 4 workspaces. But for CAM, there is some limited CAM functionality currently exposed. So through the API portion for CAM, I can interrogate all of the current setups and toolpaths that have been created and find out if they're up to date or if they failed for some reason. So I can query those, and I can post-process. I can output setup sheets, and I can generate toolpaths. So if a toolpath is out of date, I can cause it to recalculate and update a cell. And so there's some workflows that this is nice for. So if I've created a model and I have a toolpath on it, and now I automate modifying that model, then I can also automate updating the toolpaths and creating a new and post-processing on with those new toolpaths. So I could automate that. But things I can't automate is creating new toolpaths. And so that should be coming at some point in the future, but it's not here now. The API also has support for the data panel. So the data panel is kind of Fusion's interface to A360. So I don't have to go to it, A360 itself, but Fusion has this panel to the side that lets me browse my workspaces, folders in those workspaces, and see any existing models that I have, and then I can open them from here and do some other things. Right? So the API provides equivalent functionality for this, so it's really similar to the data management part of Forge, right? But I don't need to mess around with OAuth, because when I'm using the API, I'm basically that user that's logged into Fusion. I'm acting as them, and so I can just use the API to interrogate, and there's no authorization needed. I'm already that user. There's also some translator support. So this is kind of like model derivative, but again, no OAuth. I'm not having to connect to any service, but it's just whatever that Fusion supports locally for translation. And Fusion has this export command and also this new design from file command to let me read in models and export to write out. And then I'm limited to fairly small number of formats. So to do more than that, then I can use the model derivative API. But as I said before, since Fusion is saving the files to A360, the Fusion file is already there, so I can access it through the model derivative or use the model derivative API to export it in a lot of other formats. Right. So there's also some functionality in the API that's specific to the API. So there's not, it's not an equivalent to a command, but something that's only in the API. And so one of those is to be able to get detailed information from a model. And so, for example, I have this simple model here, and I could get this face, and from the face I can get its edges and find out that it has, well, first I can find out from the face, I can find out that it's planar, I can get normals from it, curvatures, different information from the face itself. I can get its edges. I can find out, this top edge, that it's a linear edge, and that edge connects to this top face. And I can see that face has two loops. It has this outer rectangular loop and this inner loop for this pocket. And so this inner loop is made up of quite a few edges. I can get their shape, interrogate them for tangents and curvatures, and then find out which faces connect to those edges. So I can really get the complete information from the model geometrically and topologically. So it's a boundary representation model of the solid surface. And sometimes I don't need that. I'm doing an application where just a triangular mesh representation of the model is good enough. And so the API also exports getting the model representation just as a mesh. And you can control the tolerance of that mesh and other factors that define how that mesh is generated. The API provides access to the assembly structure, so I can get components and find out what components are inside it. So basically I can see that a component is representing a subassembly, and then does it contain any other assemblies or parts? And if it has a subassembly, I can find out what's inside it. And so I can traverse this entire assembly structure. Through the API, I can create custom commands. So Fusion has this really nice, well-defined concept of what a command is, and I'll demonstrate some of that a little bit later. But part of that is these common dialogues that all the Fusion commands use, and so you can create these custom dialogues to get different kinds of inputs from user selections or values or all different kinds of data. The API, of course, supports creating. We have kind of two ideas of something called a script and something called an add-in. And code-wise, there's really almost no difference. It's more in just what it looks like to the user. So a script, he runs from, and I'll show you this dialog in a little bit, but he runs a command inside Fusion that brings up the scripts and add-ins dialog. And so he can see a list of all the scripts. He would choose a script from there and say run, and it would run, do whatever it needs to do, and then it's done. And if he needs to run it again, he would go through that same process again, bring up the dialog, pick it, run it. Add-in is Fusion finds that as it's starting up and will run it as it starts up. And then typically what an add-in does is in that startup phase is it will add its custom commands into the Fusion UI. And then it just sits in the background, still running, but sits in the background listening for if any of its commands get executed. And then if they do, then it would pop up a dialog like you see and interact with the user and do its thing, and then it's done. And so if I create an add-in that has these custom commands, then to a user, those commands just look like built-in Fusion commands, because whenever he starts Fusion, I just have this new functionality. And the API also supports something called attributes. So this lets me tag whatever information I want onto Fusion geometry. So I can add information that that I use to give more intelligence to this model. Or another common use is just to tag something so I can find it later, kind of a way of naming something. So some future functionality, some things that we're working on is custom graphics. So I can draw my own things inside with all the Fusion data. So these, I think, are more advanced, so it'd be more for the bigger applications would use this kind of stuff rather than the end user just writing a script. But it's all a part of that single API, and everybody can use whatever they need for whatever they're trying to do. Custom workspaces and also a custom browser. So I talked before where Fusion has these workspaces. So we saw the modeling workspace and the patch workspace and rendering. So it's a way to group functionality into, so when the user is doing that particular task, all they see is the commands for that are needed for that task, and that's a workspace. And so you'd be able to create custom workspaces, and the browser, you would be able to define what's inside that browser. And custom features. And today, Fusion supports some events, but it's not very much right now, so we want to support additional events. T-splines, so that some of those free-form models, a lot of those were done with some functionality inside Fusion that's called T-splines, a way to model, and that currently that's not supported through the API at all, and so we want to support that. I talked a minute ago about how Fusion has this well-defined idea of what a command is, and all of the Fusion commands use the same dialogues. So you can define the content of the dialogue, but how it looks and behaves is the same for all Fusion commands. But sometimes you need more than what that can do, and so we'd like to be able to support HTML-based dialogue, so you could create whatever you want. And so those are some of the things that we're working on now or in the near future, and we'd really like to hear what you need, and we can add that to our list. So we've got a big list of things we want to do, and it's just prioritizing it, and your input is very valuable to help us do that. So a little more detail about the API, how it works. And so there's this API object model. So the API is an object-oriented API where there are all these different objects or classes, And this chart, each one of the little boxes, which you can't see because it's too small, but each one of these little boxes represents a different object. And most of the objects in there have an obvious one-to-one correspondence with things you would be familiar with in Fusion. So for example, there's an object called an extrude feature, and which obviously corresponds to an extrude I would create in Fusion. And there's a sketch line and a sketch dimension. And so right now there's 559 objects defined in the API with over 6,000 methods and properties on those different functions, 82 enums. So there's quite a bit defined in that. And the hierarchy, and we'll look at this in more detail on the next slide where we can actually see it. But so this chart, so I've got a top level object, and then from that object I can get to other objects, and from those objects I can get to other objects. So there's this hierarchy of objects, and this hierarchy doesn't define class structure. It's not like derived classes and like you would see a lot of times in the maybe a C++ specific API, but that it indicates ownership. And in most cases this is fairly logical. So if I think of, I have a sketch line, what would own a sketch line? Well, it would be the sketch. And what would own a sketch? Well, that would be a component. And what would own a component? That would be a design. And what would own a design? That would be a document. And so that list that I just described, that's how this chart is laid out. If we could look and see, I would see that from a document I can get a design, and from a design I can get all of the sketches, and then from a sketch I can get all of the lines within a sketch. And so that's this hierarchy again is defining kind of that ownership. And so to get to something I have to kind of understand that ownership so I can go from one object to the other to get to the object that's important to me. All right. So now we're going to look at a little more detail at this section right here for sketching along with some code. And so here's a blow up of that section so we can actually see some of these objects. And so the kind of the most important object is this top level application object. And why it's so important is because if I get access to that, then I have access to everything else, right? So that's the gateway to the API, really. And so all of these objects, they support methods and properties, and a few of them support events. And so from the application, I can get to these objects, and then I can call their methods and properties and events to either query information, to change them, to create new things. And there's two different kind of types of objects shown here in the chart. So you notice some of them have rounded corners, and some are just rectangular boxes. And the rounded corner objects are referred to as collection objects, and they're a little bit special, so they don't correspond to anything in the user interface. They're API only objects, and what they do is they provide access to existing objects, and it's also through those that I create new objects. So for example, you can see kind of in the middle of the chart there's a sketch circles object. And so every collection, there's no exception to this, every collection has a property called item and a property called count. And so count, so if I got to the sketch circles collection for a particular sketch and I got its count property, that would tell me how many sketch circles are in that sketch. And then I could use the item property to get those circles. So if there were two circles, I could do item sub 0 would give me the first circle, and item sub 1 would give me the second circle. Right. And then the sketch circles collection also supports some methods to let me create new circles. So there's several methods because there's different ways to create a circle. So I think add by center radius or add by 3 points. And so that would create a new circle within that collection, basically creating a new circle on the sketch that I got that collection from. Right? And then there's also, it's not shown on this chart, but there's also another object that we call an input object, and I'll show an example in a minute of this, but it provides kind of the equivalent, it's the API equivalent to a command dialog. So a command dialog is used to gather input from the user. And so for example, if I want to create an extrude, as a user, when I run the extrude command, it brings up the dialog and it guides me through the input that's needed to create an extrusion. And then once I've provided the necessary input, I can click OK, and then, excuse me, and then the extrusion is created. And so these input objects in the API are basically the same thing. It's just an object that has properties that I need to define. And then once I've defined those properties, that's the input that's needed to create the extrusion. Then I can say, okay, now go create it, because you have all the information you need. All right, so let's look at some real code here, an example. So we're still going to use that sketch geometry and or that sketch portion of the API. And so here's this is Python code. And this first line, there's a library called ADSK for Autodesk, and the API is broken up into two libraries within it called the Core and Fusion. And ideally, we wouldn't have done this looking back, but at the time we thought that maybe this Core, which is just kind of general functionality, might be used by other applications besides just Fusion. But it looks like that's not going to happen. So, but Core functionality and then Fusion functionality. And so what I'm doing is specifying this ADSK namespace in the Core library, and within the Core library is the application object is defined. And on that application object, I'm calling this static function called get, and that's getting me the application object. And so now I'm tied in to this object. I have it, so I'm tied into this object model, and it returns the application object. Right? And the application object has a property called active product. So I call that, and it returns the design. So a product, the way Fusion documents work is they contain a lot of data. And so within a single Fusion document, I can have the design, so my model, I can have tool paths, I can have animation information, and those are all, the term the API gives it is those are different products within that single document. So when I get the design product, that's the modeling data that's contained in this document. And so I'm getting the active product, so I'm assuming that they have that they're in one of the workspaces that is for modeling. If I wasn't, this would fail later on because I wouldn't give back a design object. So, but anyway, so from the application, I'm calling give me the active product, and so that's returning this design object. The design object has this root component property, and so the root component is this top level guy in the browser right here called widget v1. So that owns everything inside this design. And so I'm calling the root component property to get it. So now I have in this object chart, I'm down to this component object. So you can see I'm just traversing down through this. From the root component, then I get its collection of sketches. So now we're at this object. And then I also get the XY construction plane from the root component and just save that into a variable. And then on the sketches object, I call its add method and pass in that plane. And so now it just created a new sketch on that plane, and I would see that show up in the browser at that point. Right. So now we're down to this. We have the sketch object, and then on the sketch object, I go call the sketch curves property. So we're at this object, and then I call on it the sketch circles property, which returns the sketch circles object, and I save that in this variable called circles. So now I have this object, the sketch circles object, and then it has a method called add by center radius. I pass in, so here's another object called a point 3D object, and it has a create static function on it. So I call create, which creates this point 3D object, which is just a wrapper over an XYZ coordinate. So I'm specifying an XYZ coordinate and a radius. And then that creates a new circle, and I give back that sketch circle that actually exists in the model now. And now I want to add a dimension to that to control its size. So I use the sketch, from the sketch I get the sketch dimensions collection, and I call this add diameter dimension method on it. I pass in the circle that we just created, and then I create another XYZ point which defines the position of the dimension text. So now I just created a dimension. Right? So that's kind of the basic idea of how the API works with this object model, the structure, and then how the objects support different methods and properties to let me get things and to create new things. So this is Python, and here's the exact same program in JavaScript. So you can see I'm doing exactly the same thing because it's the same API just exposed with a wrapper for a different language. And so if I go back to Python, you can see the code is really exactly the same, just there's some syntax differences. Right? I have to use the var statement wherever I'm creating a new variable, and then how comments are defined is different. So that's, and I've got semicolons. And here's the C++ equivalent of the same language or the same program. And so again, pretty similar. So there are some syntax differences between the same language. Like I said, it's always the same API, but sometimes because of just how the different languages work, there's a little bit of difference. So for example, C++ doesn't support properties. And so, but there is a get and a set that provide the equivalent functionality of a standard property. And so there's a little bit of a different flavor of the language or of the API depending on which language you're using, but it's the same API. All right, so here's just building on that sample we just looked at to see how those input objects that I referred to earlier work. So building on what we just did, we just created a circle in a sketch and added a dimension to it. And now from that sketch, when in the user interface, when I draw a sketch, and then when I run a command, so here the extrude command, as I move the mouse over the model, different portions of that sketch will highlight. And those are referred to as profiles. So they're closed areas within the sketch that Fusion has computed. And so what I'm doing here in this sample is, so my program created a new sketch, and it created a single circle in that sketch. So I know that that's all that's in the sketch. And so this is, on the sketch, there's a collection of profiles. So those are automatically computed by Fusion. So it's all of the closed areas, and I'm just getting the first one, which I know is that one single circle that I just created. So now I have that profile, and then from the root component, I'm getting the collection of, getting the features object. So I'm calling a features property on the root component, which returns the features object. And then from the features object, I'm calling the extrude features property, which returns this extrude features object. And I'm saving that in this variable. And then on the extrude features object, there's a create input. And I'm passing in the profile, because that's always needed for all extrude. The profile and what kind of operation. So this in the dialog is showing new body. Here I'm specifying new component, which is another option. So now I've kind of initialized, I've created this new input with some basic, some of it initialized. And now I need to tell it what's the extent, how far do I want this extrusion to go? And there's different ways to define that. I can say, you know, just go 5 inches in this direction, or go 5 inches in both directions, or just go up to this surface. And so in this case, I just want to go a certain distance. This first argument is saying if I want to go symmetric or not, and the second argument is saying how far I want to go. So I'm creating an object to pass in that information of how far I want to go. And so now we've defined the extent we want this extrusion to go. And so now we've defined everything we need to fully define an extrusion. And so now we can call the add method on the extrude features collection and pass in the input that we had just defined, and now that creates the real extrusion. So the best way to think about these inputs, like I said, is just the kind of the API equivalent of the dialog. It's gathering all the information that's needed to create a more complex object. So the inputs are just used for the complex objects. Like we just saw when I create a sketch circle, I just directly create it. I don't have to create an input as in an intermediate step. But for complex things where there's especially a lot of different options and just a lot of input, these input objects are used. So a little bit on choosing a language. And so Python, I think, is the best choice for if you're an end user wanting to just customize Fusion, you know, do some simple scripting or even some add-ins with some commands. But it's probably something I'm going to use for myself, or I'm happy to share it with other people too. But it's going to be the fastest language, I think, to learn and to use, and it's once you get used to its quirks, it becomes pretty nice to use. Right. So as I said, you can use it for simple things, but also more complex commands. So kind of a downside with Python is if you do share it with other people, if you deliver your program, you're really delivering your source code. So you know that's one big reason that like professional applications would tend to probably not want to use Python. C++, so it's going to be the fastest language out of all three of them. And it's also going to be the hardest one to use just because C++ tends to be just a harder language to learn and to use. So an advantage with C++ is I'm delivering just my binary. So on Windows, I'm delivering a DLL. On Mac, I'm delivering a dylib. And so one thing I don't have listed here is with Python, where I am delivering the source code and it's interpreted at runtime, I can create one program that will run on Windows and Mac. And I can probably just develop it on one or the other, and it's just going to work on the other one. And don't really even have to test it. But with C++, because I'm delivering a binary, I have to, if I want to support both, I have to compile it on a Windows machine or on Windows OS. I have to compile it for Windows, and then on a Mac machine, I have to compile it for Mac. So that's a little bit of a pain to support both systems. But so JavaScript. So it's the way the API has been implemented currently. JavaScript runs out of process, so it's running outside of Fusion and then talking to Fusion on Windows, and on Mac it actually runs inside Fusion. But anyway, because of how it's implemented currently, it's quite a bit slower to use on Windows. And because of this out of process thing, too, events have some problems. And so we just chosen not to expose events, or most of the events, through JavaScript. So there's some limitations there. And JavaScript just has some built-in limitations because JavaScript was really designed to work with web pages. It's the language to drive HTML and CSS and to control a web page. And here we're using it as just a generic general programming language, but it has built into it security limitations because of its web background. So there aren't functions to access your hard drive and to read a file and do things like that. And so for some basic stuff like that, we've actually added that into the API, the Fusion API for JavaScript. We added some additional functions to let you read and write files and do things that you would want to do. But there's other things that just aren't there in JavaScript that you can do in C++ and Python. So as you can tell, JavaScript wouldn't be my first choice. So I would look at Python and C++. All right. So to get some more information about the API, let me just demonstrate this rather than talk about it. And so if we go into Fusion, and first thing is the help. So if I go to help and programming interface, it will take you here, and there's this section in the help, this programming interface section with all the other Fusion help. And there's this page that it initially takes you to, is welcome to the Fusion 360 API. And so this has some links to some other resources. There's a GitHub site that has quite a few samples and also some videos. So about a year ago, we did just a Fusion-specific hackathon and did a whole series of videos with that. And so you have access to those videos through this GitHub site. And then there's also quite a few samples here. That object model chart, so there's a PDF of that chart that you can access from here that you can print out. And then there's a discussion group, and so this is the best place if you have questions. So myself and the rest of the development team group and answer questions that come in there. So you can use discussion group, and then I also have a blog where I post information about Fusion and the Inventor API. So this Mod the Machine blog. Okay. So to talk about a little more of what's in the help here. So they're just welcome, gives you access to some other resources. There's the What's New tab that describes what's new in the latest update. And so there's some overview topics at the top here, and then a detailed list of every new object and the new methods and properties that have been added in this latest update. And then there's this user's manual. And it has quite a few overview topics. So just how do you create a new script or add in some basic concepts, which a lot of those I've just gone over. What is an object model, objects, collections, that kind of thing. So if I just go into that one. Right. So we've got the basic concepts, how to customize the user interface, how to create commands. There's a separate topic for command inputs. Those are the things that go into the dialog to let you get input from the user. how events work, how to use those, how documents are structured inside Fusion, working with solids and surfaces, working with attributes. Remember, that's the thing where you can add information to Fusion objects, how units work inside Fusion. So all these different topics. So, and then some specific topics for if you're using C++, JavaScript, or Python. And so anyway, so this is probably the best place to start, or those videos that are on YouTube, or yeah, on YouTube. And then here, this reference manual. So this is really the guts of the API documentation. And so here's a list of all those, I can't remember, several hundred objects. And so, for example, this appearance object, and then it has several methods and properties. But so if I go to the appearance object, here's the detailed documentation for it, basically what methods and properties it supports, and which properties return an appearance object. How do I get an appearance object? But if we go look here, so here's a property. It shows me kind of an example of how it might be used. This isn't really a sample, but it is illustrative of how you would use it for these different languages, JavaScript and Python. And then quite a few of the objects do have, so let's go to one that I know has some. So let's look at extrude feature. So it's methods and properties, and then it has a topic down here with some samples where an extrude feature is demonstrated. So if I go to that, then here is some sample code that I could copy and paste in to run, and I have JavaScript, Python, and C++. And then finally, here in the help, it's just another way to access those sample programs, but so they're organized by themselves. And so if I'm just interested in working with assemblies and occurrences, so here's a sample that demonstrates that. And so it's, like you say, it's one sample that's accessed from several different points. Right. And so just to finish off, go ahead and show a few sample programs that demonstrate some of the API. And let's see, I've got so I'll just go through a few of these and say feel free to any questions to go ahead and type those into the questions panel, and I'll just keep going with samples for a little while and watch for questions as they might come up. Right, so back to Fusion, and let's start off with I guess a simpler one is, in fact, let me, if you haven't seen Fusion before, I'm going to create a simple model here. So I said I want to draw a new line, so it knows that's for a sketch, so it's going to ask me to create a new sketch. And to create a sketch, I need to pick some planar object inside the model, and so that my model's empty right now, except it does have an X, Y, and Z base planes. And so I want to create a new sketch on this plane, and it's reoriented it so I can see that. I want to work in inches. And we'll just make a real simple shape here. So all right, so there's a basic shape, and I can control its size now by adding dimensions to that. So let's say I want that to be 5 inches. Right. You can see the model adjusted as I change the dimension. Here's this one. I want this to be in a relationship to this one. So right now it's 3.2 inches, but I want it to be relative to this. And this one, all of these are behind the dimension is something called a parameter. And the parameter behind this one is named D1. So when I click this, it put D1 into this field. I can say I want this to be D1 times 0.6. Got two dots. So this will always be 60% of this one. And let's put a dimension here. And I want this one to always be maybe half of that one. And that's good enough. So I'll go ahead and stop the sketch. Now I want to extrude that. I can extrude at some height, whatever. Then we want to add maybe some other features to that. So I'll add a fillet, pick these edges. Okay. And a little more. And let's hollow it out. So I'll create a shell feature. So I'll pick the face that I want to remove and then how thick I want that. And then maybe one more fillet just around the bottom. Oops, wrong edge. Okay, so now we have this part. And as I was modeling, a whole bunch of parameters were created. So Fusion supports a couple of different ways, really 3 different ways to model. Is I can do parametric feature-based modeling, which is what I've been doing here. I can do direct modeling, which is more like where it doesn't have any intelligence. It's just I'm just pushing and pulling on faces, and the model changes in a smart way, but it doesn't have parameters driving those changes. And I can also use the T-spline, which is more like working in clay, really. I can sculpt and pull and drag. But here, there's some advantages to using this parametric modeling, because now I have all these parameters that have been created. And here's D1. I'm going to rename it to change, and I'll show you why in a second. And you can see these other parameters that are dependent on it automatically updated. Right. So now, but now if I change that value, so it's 5 inches now, I want to change it to 6, the model recomputes. Okay. And I have a little Python program here. And so it gets the application object like we saw before. It gets the active product and gets the, which is the design. And the design object has an all parameters property. And so that's all of the parameters in the design, no matter where they exist. And I want to get the one that's called change. So I'm calling this item by name property. So now I have that parameter. And then down here, I'm going through a loop where I'm starting at a certain value and going to a value and incrementing by some value. And each time I go through this loop, I change the value of the parameter. And this probably isn't going to work particularly well online because of the latency, but let me go ahead and run this. And I'm seeing a nice smooth update. You're seeing probably something jumpy, but I'm just changing that parameter. So this isn't necessarily how it would be used, but how it's pretty powerful. So I'm changing this parameter and creating a new model. And a more common thing would be I have a family of parts. So I have this part that represents a whole family of different sizes, and so I might have that defined in a table, and then write a program that would read that table and then assign those values to the correct parameters to create this new variation of the part. So I could automate building those families. All right, so let me questions come in if I can get my window big enough here to read it. There we go. And so there's a question if we plan to allow executing add-ins without launching the Fusion 360 desktop app. And that, so there aren't any immediate plans for that. So today, as I said, the API runs inside the desktop. And so the desktop has to be running to use the API. There is some functionality, and it's in the help. In that overview, there's a section called, I think, inserting parts from a web page or something like that. But it's a way kind of from outside Fusion to start up Fusion. But the Fusion client has to be running to access the API. So there are some long-term plans to have Fusion running on the cloud, like you saw with the design automation API with AutoCAD. Now to have something similar to that, so that you could control Fusion that's running on the cloud, and so you wouldn't have to have a desktop version of it running. But today that's it. And so a good follow-up question to that is, what about running Fusion in the background? And today you can't, so it's always going to be visible and come up. So there were some things, I don't know if you're familiar with Inventor or not, but it used a COM, so some functionality from Microsoft called COM, and specifically the COM automation API, and we got a lot of that stuff for free at that point just by using that type of API. So you could start Inventor but tell it to start invisibly, and then you could still talk to the API and drive it. But we don't really have a way to do that today with Fusion. So there are some limitations there. All right. So let's look at a couple other samples, and then maybe we can call it good. So here's one that demonstrates being able to query the model. And so here I have several instances of a component in different orientations in the assembly. And then I've written this command called cork all holes. So this is an add-in. So when I loaded Inventor, or loaded Fusion, sorry, Fusion found the add-in and ran it, and the add-in added this new command to the assemble panel. Okay. And so this add-in is running in the background waiting for this command to get executed. And so I run it, and it has a dialog, really simple dialog, but it's asking me to pick bodies. And so I'll maybe pick these two, and then click OK. And what it's going to do is it's using that part of the API I talked about earlier to be able to interrogate a solid model. So it's not looking for features, because this could have been read in through, say, step, and so there aren't any features. It's just looking at the shape of the model. So it's looking for basically circular edges, and then doing some additional logic to figure out which ones represent holes and which ones represent bosses, so it knows what to ignore. So if I click OK, so now it's processing away, and so it found all the holes and their sizes, and then built new models that represent these corks, and it added joints so that the cork is stuck in the hole. So a really useful program. Undo drag, because I moved the model around, but you can see here, undo cork all holes. So my command was called cork all holes, and so everything that command did is in a single undo. So if I undo, so there's undo a move, and the next one is to undo the corks, and there they go. So let's see. So there's a new question. The add-in with Sigma symbol is part of Fusion or is available as a sample? And I'm not familiar with that add-in, so I can't really say. But if you'd like to email me, maybe I can find out more about that. Oh, I see. So the question was about this symbol right here. Is that part of Fusion? And so this is just a Fusion command. So yeah, you're not seeing it in your version of Fusion just because by default it's not there. This is what you're seeing in your Fusion, is just the modify panel. And what I did, because I use that command a lot, is, and this is just part of Fusion, is if you go to a command that's in the panel, you'll see this little curly arrow next to all of the commands. And I just click that, and then that moves the command up into the panel. So any commands that you use frequently, you can put those up there. Or if there's some commands that Fusion put up at the top and you don't use those frequently, then instead of the little curly up arrow, there'll be an X, so you can remove it from the main toolbar. So it's still in the drop down, you still have access to it, but it just lets you manage what's in the top level. All right, so let's look at another sample. So this one is kind of fun. It's something, let's see, let me do this one. It's something we did for the Forge conference with a couple of partners. And so we had these stools that had been machined out of a solid piece of a big sheet of plywood. But then we wanted people to be able to customize a design for the top of the seat. And so we wrote this little program. So got several commands here, and you can see, so this is an add-in, and you can see that you have really full functionality like a built-in command to be able to do nice commands. So I have these previews that show up, and anyway, I'll just show you a couple of things. So this was to try and make it easy for non-Fusion users to create sketches, basically. So if I do this mesh command, so it's just drawing lines in a mesh shape, and they're kind of randomly placed, the points on the mesh. Or I could say I don't want it random and get a nice rectangular mesh. And then if I click OK, it just creates sketch geometry that's like that. And there were some other shapes that I could do. And then at the end, I could say cut seat. And basically this, then there's a Python program that would read the sketch geometry and convert that into G code and send it to a machine where we would cut the top of that. So just another example of the API. And then let's see, and just these command inputs. So different ways to get input from the user, right? Okay, so I just encourage you to go to that help page to read more about it. And oh, one more thing. So this scripts and add-ins command. And so here is where I access all of my existing scripts and add-ins. But what I want to really point out here is there's some sample scripts and add-ins that come with Fusion. So you can look at some of those and play with them. And for example, here's the gear example I was talking about. And I'll just run that. And there we go. So I encourage you to look, and I thank you for attending. And if you have any questions, the Fusion Customization Forum is the best place. So thank you.